Okay, so welcome back, and we're going to dive straight back in. We're on page 47 and we're looking at question number 46. Okay, so here we've got some numbers that have been prime factorized, and we now want to find the HCF. Now remember that the secret with the HCF is we only write down those bases which are in all the numbers. So 2 is in all the numbers, 3 is in all the numbers, and 5 is in all the numbers. Okay, now what we need to do now, we need to make sure that we've got, we can't have more 2's than exists in the smallest number. Okay, and the reason being is that we need a number this number is going to need to divide into these numbers. So it can't have 3 2's. If it's got 3 2's, it's not going to divide into that one. So in fact, what we're going to do is we're going to take the lowest number of 2's that exists. We've got 6 and 3 and 2, we're going to take 2. We've got a 3, a 3, and a 3, so we're going to take 1 3, that's the lowest number, and we're going to take 1 5. This number over here, which happens to be 60, when we multiply it out, is the highest common factor. Now remember, with the lowest common multiple, what we're going to do is we're going to take all the bases, all right? All of the bases. And that will give us, let's see what they are. So we're going to take 2, we're going to take 3, we're going to take 5, and we're going to take 7. Now we're going to take the highest number of each that exists. So we're going to take 6 2's, we're going to take 1 3, we're going to take 2 5's, and we're going to take a 7. And it's fine for us to leave our answer just like that. We could multiply those numbers out using a calculator, all right? But let's just leave our answer like that for now. The number of factors that 2100 has. Now 2100 is 2 squared times 3 times 5 squared times 7. 2100 is 2 squared times 3 times 5 squared times 7. And remember, any factor of 2100 has to be a combination of factors of 2, 3, 5, and 7. We've got 3 choices for the 2's. And you might be surprised that we've got 3 choices, but remember, we don't have to have any 2's. We can have 0, 1, or 2. We've got 2 choices for the 3's, so we're just adding 1 to the power, because we could have 0 or 1. We've got 3 choices for the 5's. We could have 0, 1, or 2. All right, and we've got 2 choices for the 7's, so we could have 0 or 1. If we multiply those numbers together, we get 24. And that is the number of factors that 2100 has. Let's look at 600. All right, 600 has been prime factorized for us. 2 cubed times 3 times 5 squared. 600 is 2 cubed times 3 times 5 squared. Okay, so the number of factors, we're going to have a choice of 4 times 2. We're adding 1 to the powers each time. That's 8 times 3. In fact, we're going to get 24 factors as well. 600 also has 24 factors. All right, this business of counting number of factors is not actually specified in the syllabus, so don't worry if you're not able to do it, but I don't think it's that difficult. Okay, let's look at what's the smallest number which 600 could be multiplied by to give a perfect cube. Now remember, to get a perfect cube, we're going to have to take our factors of 600, and here they are, and we're going to have to divide them into 3 identical groups. For a perfect cube, we want 3 identical groups. Now the 2's are great. The 2's are going to be perfect because we've got 3 2's, so we can put 1 in each group. The 5's, we've got a problem. We need another 5, all right? And the 3's, we need 2 more 3's. If we multiply 600 by 5 times 9, which is 45, all right, then we will end up with a perfect cube, because our answer will have 3 2's, 3 3's, and 3 5's, and we'll be able to split them up. Okay, now we ask about 960. Now 960 is 2 to the 6 times 3 times 5, all right, and we want to make a perfect cube out of that. 960 is 6 2's times a 3 and times a 5. That's its prime factored form. All these numbers are prime bases. Okay, the 6 2's can we split 6 twos into 3 equal groups? Yes, we can. Ayikho inkinga. All right. But we need 2 more 3s. All right. And we need 2 more 5s. So we need 3 times 3 times 5 times 5. All right. 3 times 3 times 5 times 5. That's 9 times 25. It's actually 225. All right. 225. If we multiply 960 by 225, we will have a perfect cube. Right, if you haven't tried these next couple of questions, pause the video, then let it play again, try them, and then let's see how we go. Okay, so 1 and 64 are the first numbers which are both a perfect square and a perfect cube. All right, if we look at 64 and we prime factorize 64, 64 is actually 6 2's. All right, it's 2 to the power of 6. So now remember, 2 is the smallest prime number. 6 of those is really cool because you can split 6 2's either into 2 groups of 3, so in other words, like that, which would make a perfect square, or into 3 groups of 2, 2, 2, 2, which would also make a perfect cube. Now the next smallest number that we can have 3 of is, so that we can have 6 of, would be 3 to the power of 6. Right, 3 to the power of 6 is actually 729. And 729 is the next smallest number that is both a perfect square and a perfect cube. Let's just understand why. 729, we could either write it as 3 times 3 times 3 times 3 times 3 times 3. All right, we've grouped 3 groups of 2 lots of 3. So the cube root of 729 would work out exactly to just one of these. In other words, it would be 9. Right? But the other thing we can do, because we've got 6 of them, we can split our 6 3's into 2 identical groups. How many would we have in each? Obviously, we would have 3 in each. And if we've got 3 in each, then the square root of 729 would just be one of these groups. It would be 27. So 729 is both a perfect square and a perfect cube. The next one, we would have to use 6 5's. 5 is the next prime number. We need 6 of them. It's an enormous number. Okay, right. Let's look at this question. A shopkeeper has 320 sweets. She puts 25 in each bag. How many bags will she need? Right? Now we could try and do this by division, but let's just pause the video if you haven't tried it and then try it. Otherwise, let's continue and see. Right, suppose she puts 10 in each bag. Right, if she puts 10 in each bag, she's used 250 sweets. Okay, 250 sweets. That's if she's put 10 in each bag. So in fact, she could have some more bags because she's still got 70. She's still got 70 sweets left over. All right. So if she has some more bags, let's go with another. So yeah, this was 10 bags. 10 bags. Okay. How many more bags? Sorry, how many more sweets has she got? She's got another 70 sweets left at this stage. So if she puts 70 sweets into another 25 sweets into another 2 bags, that would be 50 sweets. So if she had 12 bags, she's actually used 300 sweets. All right. And can she do another bag? No, because she's only got 20 sweets left. So the final answer to this is 12 bags, 20 left. 20 sweets left. Okay. Right, there's lots of ways of doing that question, but hopefully we're getting better with numbers and we can work that out. All right. Lindiwe goes to the shop and buys 19 pawpaws costing 13 Rand each. She pays 250 Rand. How much change does she receive? Well, let's take a look at this. Okay, 19 times 13, I think that's quite difficult to work out. But if we took 20 lots of 13 and then subtracted one lot of 13, is everyone okay that that's the same as 19 lots of 13? That's how much she spends. Now, 20 lots of 13 is actually quite easy to work out because 2 lots of 13 is 26 with a 0 on the end, 260, minus 13. All right, 260 minus 13, not too bad. Let's take off 3 first, so we get 257, and then let's take off another 10. So watch what we're doing. We're doing 260 minus 3 minus 10. Are we happy that that's the same as subtracting 13? Yeah. All right. So we get 247. 247 is what she spends. All right. Lindiwe spends that. So how much change does she get? Her change will obviously be the amount that we need to add to 247 to get back to 250, or 250 minus 47. Her change is 3 Rand. All right, this next one, 27 identical items weigh 1,485 kilograms. Now we could do this by long division, right? But we could also just try and do it by guessing and checking. All right? If each one weighed, let's say if each one weighed 50 grams. Okay? Now, what would 50 times 27 be? Okay, so we're just taking a guess. Let's just say that each weighed 50 kilograms. Sorry, not grams, 50 kilograms. Okay, what is 27 times 50? Okay, so 27 times 50 is not too bad because it's 27 times 50. Right, and what I want us to think about, 27 times 10 times 5. Are we okay that this is just 50? This is 50. Right. Now 27 times 5 is not too bad because it's just 20 lots of 5, which is 100, and 7 lots of 5, which is 35. So it's 1350. Right? It's 135 and then times the 10, 1350. We're going to get 1350 here. Okay? Now, that's fairly close. Okay? How many kilograms are left? Well, there's still 50 to get to 1400, and then 85. There's still 135 left. Right. Let's see how we could share 135 by 27. Okay? So now this is a much simpler thing. We're doing 135. What times 27 will give us 135? Right? We're doing 27 into 135. Okay. And in fact, 27 times 5 is 135. So we've got another 5 kilograms. Final answer, 55 kilograms. Okay. We could have done that by long division as well, right? But either way, your mental arithmetic needs to be quite good. Okay, the next one. Vienna sausages come in packets of 8, while rolls come in packets of 6. Now, Nancy Kinga, because if we buy a packet of rolls and a packet of sausages, we are going to have some leftover rolls. But if we buy 2 packets of, we're going to have some leftover sausages. If we buy 2 packets of rolls, then we're going to have leftover rolls if we only buy 1 packet of sausages. What number are we looking for here? We're looking for a common multiple. We're actually looking for the lowest common multiple of both numbers. If we look at our sausages, if we have 1 packet, we've got 8. If we've got 2 packets, we've got 16. 3 packets, 24. 4 packets, 32. Let's look at our rolls. Our rolls come in packets of 6. If we have 1 packet, we've got 6. 2 packets, we've got 12. We're looking for an overlap here. If we have 3 packets, we have 18. And if we have 4 packets, we've got 24. Right, so here's the answer. The lowest common multiple of 6 and 8 is 24. So what we need to do is we need to buy 1, 2, 3 packets of sausages. And 1, 2, 3, 4 packets of rolls. And how many hot dogs will we be able to make? Well, we'll be able to make 24 hot dogs, and there'll be no leftover rolls, and there'll be no leftover sausages. Okay, that brings us to the end of this module, our first module. There's loads of space for you to make up some extra examples. There's also space for you to practice with your teacher your calculations. Okay, and in the next lesson, here's some powers of 2. 2 to the power of 1 is 2. Right, try and learn some of these. Here's the square numbers. Try and learn some of those as well. Make sure we know what our prime numbers are, especially the first few, up to say 20. But see if you can maybe learn all the prime numbers less than 100. There are 25 of them. Next time, we're going to start talking about integers, positive and negative numbers. We look forward to seeing you then.